I'm going to give you a lecture on project management. My name is Alexander Kinnaird, and I work at the European Space Agency. A little bit about me. So as I said, I work at the European Space Agency. I live in the Netherlands, and I work at ESA's ESTEC site, which is the technology center of ESA. My background is in space system engineering. So I did my degree in the UK at the University of Southampton, and I picked up a few other qualifications and recognitions of my work as a system engineer and also as a project manager. My work background is mainly with student experiments and student CubeSats. So I've worked here at ESA as a young graduate trainee. I also spent some time working as a payload manager for sounding rocket and stratospheric balloon experiments, living in Sweden. And most recently, I've been an engineering and program coordinator for university student activities, both on rocket and balloon experiments, but also now on CubeSats on the Fly Your Satellite project. I've also worked with the training and learning program, where I had the pleasure of developing the Space Systems Engineering training course. And you can see some nice photos about the work that I've done here with CubeSats and with rockets and with orbital launches as well. I don't just do engineering and project management. I also like to get out of the house and when possible get into the mountains and going skiing. That's why I chose to live in the Netherlands, one of the flattest countries in Europe. And I also like to tinker. And for those of you that don't know what tinkering is, maybe the engineering students will recognize the process where you're taking things apart to find out how they work, desperately hoping you keep all the bolts and be able to get it back together again. So this is the objective of this presentation. I'm hopefully going to help you understand fundamental project management principles, and in particular, the concept of work breakdown structure and how that leads to something called task-driven project planning and how that links to resource management. And I'm going to talk a little bit how to apply these appropriately to a university hands-on project. What we will go through is a bit of a justification for why you should be putting some effort into project management, and then the way you can start to look at your project or your product, so different ways to break down the project and product. And then this focus on work breakdown structure in particular, which is going to include some work package definition, how to estimate the duration of work packages, and then how to translate that into like a plan of how you're going to really attack your project. And this is project planning, looking at project flow and task-driven project planning. And then who's going to do the work, resource allocation and adjustment, how that's managed, so resource management, and then something called the critical path method and tracking. And in the end, we're going to try and take a look at how this all really applies and what's proportional for use in your project. So why should you be investing time in project management? What is the kind of fundamental justification for doing this as part of your project? So something we hear a lot in project management is something called the golden triangle, how to balance the three concepts of scope, time, and resources. So scope is really what you're trying to deliver. This is how big a project you're delivering and potentially the quality of the end product. So of your experiment, of your CubeSat, etc. Time is relatively self-explanatory, how long you have to do it in or how long you need to be able to do it in. And resources is what you have to be able to do it with. So this is people, this is money, and it might also be facilities, etc. We also use project management as a way of managing expectations. So that can be expectations of your stakeholders, people who have an interest in your project somehow. And it can also be expectations of people involved in your project. So they're really the team members. One of the key principles of project management is also risk management. So the identification, assessment, mitigation, and communication of risks. But I'm not going to go into that much further in this presentation. Finally, one of the main justifications for project management effort in student projects is being able to distribute work over the project duration. Having a good understanding of what the total scope of the project is and how much work is involved allows you to plan effectively so you're not backloading the project. You can see here an S-curve, a project S-curve, which is where typically the project will ramp up slowly, and then you have like a really delivery phase in the middle where you're working quite consistently, and then a slow ramp down, and you can produce this total cumulative effort of an S-curve. What's perhaps more typical in student projects, and I think some of you will recognize this, is actually you have really a dip in the middle of the project where you're not building cumulatively. Maybe this is summer holidays, maybe it's exam periods. And as you get closer and closer to the deadline, your workload ramps up, and the total cumulative hours ramp up as well. This is something you really want to avoid in student projects, but especially in student projects where you're building something like hardware. This is the phase where you're working on flight hardware, the things that you're actually going to fly, and you're doing testing. So it's not really the time you want to be pulling like 18, 20-hour days. So let's begin on how to tackle our student projects. Some of you from system engineering backgrounds might recognize some of the things on the slide now of ways to break down your project or your product. So things like function trees, specification trees, and product breakdown trees are really kind of system engineering tools. And these are tools you might use to try and understand what it is you're trying to build. A function tree breaks down your overall product in terms of what it's trying to do, so its functions. A specification tree or requirements traceability matrix breaks down your product in terms of basically what you're allowed to produce. So it will talk about function, but it'll also talk about operations and about design. And a product breakdown structure really makes the transition from those kind of abstract concepts to start talking about really products. So physical things that you're going to build, and perhaps also things that are going to support it, like around support equipment, models and tools, etc. The first breakdown that we talk about in terms of project instead of product is a work breakdown structure. This is principal in managing the project and allows us to create kind of a good understanding of the overall scope of what we need to do. Other project management tools, we might come across like organograms, responsibility matrices, RACI diagrams, but I'm not going to discuss those too much in detail here. So let's look at this work breakdown structure. What a work breakdown structure does is kind of break down your overall project into tiny bite-sized pieces. The idea being you don't really get a good idea about the whole scope of your project just looking at where you are and where you need to be. You need to start thinking about the steps in between. So we make these bite-sized pieces of a project called work packages. Our work packages can be different sizes, different scopes, and it depends where you are in the project as to how broad a work package you make. But in general, you need to think about, okay, what is each thing needed to be done? So what deliverables do you need to do? What is the scope of the work package? Is there some kind of budget needed? Is there a responsible needed, etc.? There's different ways to start breaking down your project into this work breakdown structure and defining these work packages. So you might start with something like the product tree, and you'll see an example on the next slide which is going to explain this, and then start adding some work packages, some verbs underneath this. You might use a phase-driven approach where you think what needs to be delivered each phase, or you might use some combination of both. And important to know is that the work breakdown structure is refined and updated through your project progress. So here is our example of a work breakdown structure. As I said, we start at the top. It starts to look something like a product breakdown structure. You see that we start with our overall deliverable, and in this case, it's a demo sat, a satellite. And we break this down in space, we call these segments. So we have a space segment, a ground segment, maybe some supporting infrastructure like a ground support equipment, then some subsystems. But then we start to define work packages. If you have to ask yourself what's the difference between a subsystem and a work package, one of the good things you can look at is whether there's a verb involved. So generally a subsystem or part of a product breakdown is just a noun, what it is I want, a payload. A work package is what I need to do. It's a design, it's a definition, it's a requirement, it's a build, this kind of thing. And you can see here that this will quite easily be able to break down this demo site into multiple levels, starting with our product breakdown and then going into our work packages. And eventually you'll get a bit of an idea about the overall scope of the work needed to be done to be able to deliver, in the end, our demo site in this case. So once we've broken down our project into these kind of high-level work packages, we need to start to add a bit of flesh to what is a work package. And the reason why we do this is we can start to, first of all, understand whether our work breakdown structure is complete, and then we can start to, build up our project as well. And some of the information we get from this fleshing out of the work packages will help us identify the project plan later on. So here I put some of the key characteristics of work packages that you need to add to your work packages or to your work package definition to be able to help inform your project planning. So first of all, your work packages have to be identifiable. This is easy. You just add a number. Here we can see the example, WP structure 3.2. You have to assign a responsible. This is partly to do with resource management later on. So here it can be a team or it can be an individual. In our example here, it's actually a subcontractor or company. You have to define the deliverables or the objectives. And these are the things which you have to think, okay, once this work package is complete, what do I expect to have? And this is really important for work package definition. Sometimes you might have prerequisites, things which need to be in place before the work package can be completed. You'll need a clear description of the task. Sometimes this might reference an external document. Maybe you need required resources, facilities, etc. And sometimes you also have successor and predecessor work packages. So these are work packages which can only be done either after this work package has been completed or must be done before this work package can be started. So one of the other key characteristics of a work package is determining how long it's going to take, work package definition and duration estimation. So it's a bit of a trick to try and work out how long it's going to take to complete a work package. It's essentially based a bit on experience, but in the end, it's a kind of guess. So different ways of doing it. You can do some research. You can think about your own experience. You can ask experts. Perhaps people have done this kind of thing before. Some of you are participating in educational programs, so you might actually be able to access documentation of teams who've done similar things. And that can help inform work package duration. Even if it's high level, it'll give you a good idea. As I said, you have your own experience. You can extrapolate from that or interpolate from that. You can also make use of things like 3-point estimates. It looks complicated on the slide, but this is actually quite a simple equation for estimating how long a project or work package might take. And also actually gives you an indication of adding some kind of buffer or adding some kind of margin to your work packages. Now we've defined how long the work packages are going to take, and we've kind of used this and closed the loop with our work breakdown structure. We've got a good idea that we've kind of captured the whole project, or captured the scope of the whole project, and now we can start looking at the plan of the project. We know what we need to do, but we don't know how long it's going to take. And this is the concept of task-driven project planning. So we let what we need to deliver determine when we can deliver it. For some of you, you'll think, okay, this isn't really how projects work. Someone tells me when I need to deliver, and then I need to work out what I need to do. But in reality, if you're going to deliver a fixed thing, a fixed scope, a fixed quality, your tasks are going to drive that delivery date. And if your delivery date is fixed, perhaps you need to negotiate then on the scope of what it is you can deliver. So we kind of have two endpoints of how we can deliver this project. We can complete all our tasks concurrently in an ideal situation, and this is the fastest possible way we can deliver our project. So this really limits the quickest way we can deliver a project. The project duration must be longer than or equal to the longest task duration. And I've displayed that on this diagram here. So this is the beginning of our Gantt chart, a chart which shows how long it's going to take to deliver our project. On the flip side, the longest possible duration of our project is if we do all the tasks sequentially. We can only do one at a time. So that also tells us how the maximum duration of our project based on the estimations we've made of our work package duration. So therefore, the project duration must be less than or equal to the sum of the work package durations. This isn't how projects really work. So when we defined our work packages, you remember I spoke about predecessor and successor work packages which must be done before another can be started or can only be done once one is complete. So now we can kind of see that we might have a network or a flow to move through our project. And we have these called what we call task interdependencies, predecessors, successors, and we can build what you see on the screen here is a network diagram showing us the order the task must be completed. What we don't see well in a network diagram or other ways of visualizing projects like a PERT diagrams, if you don't get a good visual indication of what the shortest route is through this project or what's driving project delivery. And that is something we do with a Gantt chart. So here, it's the same information on the previous slide, but here the physical length of the bars is explaining how long each work package takes. Compared to the network diagram, we can see that the top path is explaining that okay, this is the longest duration, or this is driving the project delivery, and this is what we call a critical path. So this critical path tells us basically when our project is going to be delivered. So this is where we should think about focusing resources. And one of the things you can think about is any delay on any work package on this critical path will delay the overall project delivery. Whereas a delay on any other work package that's not on the critical path will have, no effect on the project delivery until it becomes on the critical path. And I'll have an example of that later on. One of the next steps you might want to take is considering your resources. So remember when we talked about work package definition, every work package has an assigned resource. This might be a team, it might be an individual, it might be a subcontractor. You can see here that we've assigned the resources to these work packages. But do you see a problem? Maybe if I zoom in to the beginning, you can see here that we've assigned the resources, but actually the first three work packages are all being undertaken by the same resource, by John. Now, maybe this isn't a problem. Maybe John can work concurrently on three different work packages, but let's assume every work package is taking 100% of John's time. Now we have an issue. So we've been able to break down our project using the work breakdown structure, and now we know how long it's going to take with our critical path method. And now we can apply resource allocation, and we can already see, okay, we're going to have to make some adjustments on the ideal situation because perhaps John is not able to work 300% of his time. So what can we do? So this is a resource utilization graph. So this is showing the same information, but it's showing how much each one of those resources is working. And red indicates an overallocation. So you can see the overallocation here of John. So he's working between 300 and 200% of his time. But interestingly, you can also see an underallocation. So perhaps in a student project, this isn't a big problem. You don't have anyone working at that time. That's fine. They get on with someone else. If you're running a professional project, normally resource underutilization means they're also not doing anything, but you're still paying for them. So maybe this is also something you want to tackle. But let's say, okay, our fundamental problem here is the overallocation of John. What can we do? We can shift the schedule. So let's assume John can only work on things 100% of his time. So he can only do work sequentially. So what do? Is we look at the different work packages and we shift them along. We adjust our whole project plan based on the availability for John. Can you see what's happened here? So we had before our critical path at the very top of our chart was driving our project delivery. But now actually our project delivery is being driven by a totally different task, a task which was formerly not on the critical path. In fact, in this case, it was even a standalone task. But John has made this the critical path because John can't get on with his tasks or can only complete his tasks sequentially because they take 100% of his time. So by going through the resource allocation process, we've already seen, okay, the critical path is not the be-all and end-all. We have to also consider who's available when. You can see on the bottom the resource utilization. So apart from the very last part of the project, everyone's only working a maximum of 100% of their time. But there's something else we can do instead of shifting the project around. We could reallocate the resources. This way we tackle both the overallocation and the underallocation. So in this case, a bit of shuffling around, we can keep our same project plan. We reassign some of the underallocated resources, so they're now working, and we free up John's time. We deliver the project on time, and people are working more of the time. We can deliver our project. We have to consider something important here. It's resource appropriateness. So especially in your projects, you might have people who are just focusing on one aspect, perhaps electrical engineering, mechanical engineering, product design, and it's probably not appropriate to start moving them onto different aspects of the project which they're not trained for or not able to complete. Resource appropriateness is quite important. Something else to consider is simply adding more resources to work packages does not necessarily get them completed quicker. So a bit about resource allocation and project adjustment. So as I said, you have resource over and under allocation. So you can recruit more resources as well for outside your team. You can allocate existing or recruited resources to work packages. So you can try and decrease work package duration by adding more people. But this sometimes doesn't work. In the end, probably what you do is some combination of both recruitment, reallocation, project adjustment to meet the resource availability. You have to consider some other things as well when you're doing your overall project adjustment and project planning. You're not working in free space. You will have some delivery milestones. Perhaps you'll have some documentation you have to deliver. You have to be at a certain level at a certain point. You'll have some kind of launch date or readiness date that you have to be aiming for. And you have to adjust around this. You'll also have real resource availability. Not every person is available 100% of the time. They'll have holidays, exams, downtimes. You also have low and high resource work packages. The general concept is assuming that every work package takes 100% of someone's time, but it's not always the case. Some work packages are really slow burners. They take a long time, but only a little bit of resource. Some work packages, really high, intense work packages, might take someone 100% of their time, but for a very short period. And you kind of have to balance that a bit in your project planning. Sometimes you have to consider the availability of other resources like facilities, test facilities, manufacturing facilities. And you also have to consider the things you need for your work packages, so some of the prerequisites. And in particular, I urge you to think about things like long lead items, things you must order many months in advance to be able to start your build or your test. That's how you set things up at the beginning, but things move on. Your project will evolve. You can see here, this project that we've been talking about has begun, and we've started to progress through some of our work packages. This is indicated by both the task completion column and the shading in the work package bars. So you can see the bars are shaded if they're complete, or partially shaded if they've begun but not yet complete, and not shaded if work hasn't begun. You can see here this is our original critical path, and I've added a date line to indicate where we are today. Now that I've added the date line, you can see actually, okay, some work packages are completed a bit ahead of schedule, and in particular, one work package is a bit behind. So do you see what the implications of this are for our project delivery? If we look at our original critical path and perhaps where the delay is. If I add a progress line, which shows the progress essentially for our project to the completion of the work packages, you can maybe start to think, okay, so things have to shift to reflect the real situation in our project. So what we actually have to do is we shift all the work packages, so everything, all the completion points are after the current date line. So in this case, actually, we jump over a weekend. So normally you would try and keep your progress line lined up with the date line, or as closely lined up with the date line as possible. And what we've done here is we've shifted everything to really represent what the project status is. And we can see actually, okay, we've created a secondary critical path. So this is interesting because it means, okay, we've worked very hard on our main critical path. We've also completed another task, which wasn't on our critical path. But now we have this third path, which has become critical, perhaps because we were focusing on the first critical path. So now we have to think about reallocating resources and really where we want to focus the effort in the project. And that's based on the reality of project planning. You had a work package duration estimation. You didn't really know how long these were going to take, and now the reality starts to hit. So it's important to continually monitor this. Depending on your project duration, this could be weekly, it could be monthly. It also depends on the fidelity of your overall project planning. When you see project or work package elements or projects start to slip, you can make some adjustments and you can say, okay, actually, now we need to focus on this, otherwise that's going to delay the whole project. And without this kind of methods, without these Gantt methods, it's really difficult to see that when you've got a delay on something which wasn't originally on the critical path, whether it's going to affect the overall project delivery. And that's one of the most powerful aspects of critical path method project monitoring. So there's our new critical path, or actually a parallel critical path in this case. So some tips for meaningful project management. So something I like to say is please consider planning horizons. It's quite difficult to understand the full scope of your project at the beginning, but you might have quite a good idea about, you have a big picture idea and then a good idea about the very short term. So this is the kind of planning horizon. You have a predictable part, an uncertain part, and kind of a very unpredictable part the further away you go. So something important is to consider that. Other tips, use a calendar to mark your key deadlines for facilities, for booking, etc. Be sure to impose those long lead items on the whole project plan. If you're planning in stages, so a lot of programs are set up in stages, plan the next stage in proper detail. So really go into detail stage by stage, and then a little bit wider planning or more, less detailed planning the further away you go. And make sure you plan successor work packages. So as I said, these work packages which lead on from your current ones, plan those in detail, and watch out for project creep. So this S-curve versus the student curve we saw at the beginning, this is a classic example of project creep with fixed deadline. So because your deadline doesn't move, but your project has crept, so you've kept pushing things further on, or you've kind of expanded your scope, but then got no more time, you end up backloading the project. And this is something that you really need to watch out for. Something else you need to consider, you're not a robot, and no one in your team is a robot. You have to consider the resource management. These resources are people, they're students, they're friends, they're colleagues. So it's very important to keep motivated in student projects. And you can actually use project management to help you with this. So you can use project management to ensure that every team member has a role, and things like the work breakdown structure and the Gantt chart let them know how it fits within the team. So they can see, okay, the piece of work that I'm doing right now is driving project delivery, or it's not driving project delivery, but it's important, so X, Y, and Z can get on with that bit. You also need to consider that every person in your team probably has personal needs and commitments. They probably have different motivations for participating in the project as well. Individuals have different team roles. Just naturally, some people are team leaders. Some people want to work in isolation. Some people want to work really in the team. And you can do things like the Belbin test, which help you identify these different roles. You might have some kind of boring tasks in your project, or tasks which are perceived as boring, and it's important that these are either shared out, or perhaps it's someone in your team who particularly wants to tackle these. One tip I can give is use milestones as psychological targets. If you have reviews, like a critical design review or document delivery, aim for this and then reflect on what you've done, and use that as a bit of a celebration point to show the progress for your project. You might be asked to do outreach, so this is something a bit aside to your normal engineering or scientific work. And you can also use this as team building, and you can use it again to celebrate what you're doing. You can run events to share the good work that you're doing as well. Yeah, by sharing progress and achievements with stakeholders, it really helps you keep motivated, especially if you're explaining to new people who can be very excited about what you're doing. Really important, take the time to reflect. So at the beginning, you have this big task of planning your whole project, but you'll very quickly get on with moving through it, and it's quite easy to forget about all the work you've done in the past and just how far you can go in quite a short period of time to building, testing and operating some kind of experiment or space object. That's a bit of the theory. In reality, things don't always go to plan. Things don't always go to plan in professional projects. We see that all the time in the news. Things don't always go to plan in student projects. So you have to know, okay, what you have on paper and what you have in reality tend to be different. That's normal. Project management helps you deal with this. So project management can help you deal with things when things go wrong. It can also help you, tune your project as if it doesn't kind of progress as you expected. One thing I will say is that project management in student projects, you should be using this as a tool, not a chore. It's quite easy to see project management documents as a chore, something you have to deliver, but it should be something which is helping you with your project. And it should be something which is proportional to the overall project scope. So invest time in project management and planning, which is proportional to what it is you're trying to deliver. Don't spend 12 hours on project management and 10 hours on engineering. You might consider the effort to be the same. So 10 hours on project management, 10 hours on engineering. Depends on your project makeup and the people in your team. Another thing is project management is used as a way of reporting. So you will have some stakeholders who want to know how your project's going. Communicate to them in a meaningful way. So don't deliver a 4,000 line Gantt chart and work breakdown structure to someone who just wants to know, will you deliver on time? But likewise, if you do have someone who's reviewing your project management in detail, think about which information they need. Probably if you're participating in a program, you'll have some kind of reporting documents. They will have some document requirement definitions or some kind of guidelines. Read those carefully and deliver what it is the people who are reading that want. A little bit about tools. So there's many different tools you can use for project management, and these are just a few of them. Typical ones, Microsoft Project as part of the Office suite is very good, but of course you need a license for this. There's some free tools out there such as Gantt Project. You can also build your own tools in Microsoft Excel. There's a lot of collaborative tools out there such as Slack, Asana, and they have plugins and things which are very powerful. It all depends on how you want to work with your project team. I will say one of the easiest things you can do actually is to do this very physically. You can even, if you have small teams and you have a dedicated room or lab that you're working with, you can even build Gantt charts and word breakdown structures using sticky notes and string. Very visual way of understanding what's happening, at least just a big project idea. Very easy to understand, okay, tasks are completed, tasks are delayed, and how things relate to one another as well. So don't underestimate the simple ways of doing project management and project planning. So in summary, I hope I've been able to explain to you a bit about project management, and that project management ensures expectations are managed and projects can be achieved within a given time and with given resources. This is our golden triangle. Projects can be broken down in a number of ways, but we focus particularly on work breakdown structure, breaking down into work packages. And task-driven project planning, and the example I used was Gantt, allows the identification of a critical path. So this is the network through our project which drives the duration. Resource allocation ensures the right people are available at the right time. And in the end, you should be investing effort in project management, which is proportional to the overall project. So in addition to these points, I'd also like to let you know that project management is not a discipline that exists in isolation. It's not just something the project manager is dealing with. And as we saw on the resource management slide or the EQMA management slide, teams exist as a group of people. So project management is something which involves the whole project team. And in fact, it doesn't work unless it involves the whole project team. There's no way the team leader can know exactly what the progress is on your work packages. And there's no real way they can know how long a work package takes. Or may take unless they're speaking with you and you are the experts within the team. So the message is that project management is really a whole team effort and not just something which is aside and done just by a project manager. I've included some further reading for those of you that are interested. So there's a few ECSS there and also a document or a book on risk management for engineering projects, which I haven't covered in detail here, but is an important aspect of project management. So I hope I've been able to explain a bit about some basic project management principles, but if you do have any questions or you want to know more about anything you've seen in this presentation, feel free to reach out to ESA Education, and they should be able to help you with your project planning, and in particular be able to apply some of these concepts to your projects.